I pressed record. Can you still see the zoom menu that I'm at?
Yes, sir.
Yes, sir.
Like I can see, you can see my picture and Farabi Abrisam's picture, right?
Yes, sir.
Yes, sir.
Beautiful. This is functioning the way that's working. So I pressed record. So I hope the lecture is recording. I don't know where it is recording. If it is recording in the cloud, which is the best thing, so that I can download it later and upload it. If it is not recording, can any of you who is using the PC record this lecture? Do you have that capability?
আপনি পারমিশন দিলে করতে পারবো কিন্তু
It
আপনি
cannot. How do I permit you?
I think co-host
Screen
বানানো
record.
লাগবে কাউকে।
So I am in here. Now I don't know if I'm recording this, so I just want it to be.
Sir, record হচ্ছে,
Yes,
record
sir,
হচ্ছে।
you're good. Hot
Sir,
sir.
it's being
Record
recorded.
হচ্ছে?
হ্যাঁ,
Yes,
sir.
sir.
So
Yes, sir.
for those who are accessing it from the PC, the record button on the top option, that is, I mean, circle and red, that is actually on, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Beautiful. So if it goes off at any point, notify me so that I can redo the whole thing. But I hope it doesn't happen. This is actually pretty nice. All right. So let's go ahead with the MCQ paper. Have a look. 7.1, it says, which of the following summarizes the change in the wave characteristics ongoing from infrared to ultraviolet in the electromagnetic spectrum. So if you go from infrared to ultraviolet, what happens to the frequency? What happens to the speed in vacuum? So what do you think? From infrared to ultraviolet, what happens to the frequency?
Sir, infrared to ultraviolet frequency bar.
Infrared to ultraviolet frequency bare, beautiful, and speed in vacuum does not change.
Image
আচ্ছা
constant.
এরপরে দাঁড়াও এখানে দেখি Number 5 টা দেখো which observation indicates that sound waves are longitudinal আচ্ছা এখানে এটা কারেক্ট রেসপন্স হচ্ছে sound waves cannot be polarized. There is a reason for this. Only and exclusively transverse waves can be polarized because the property of the transverse wave is that as long as the particle vibration is perpendicular to the direction of the wave energy flow, we can call it a transverse wave, which means because it only have to maintain that perpendicular direction thing. So it is pretty easy, to be honest, so like super easy to have a lot of different alignment for that particle movement, which can be perpendicular to the direction of the wave energy. So that's why transverse waves can be polarized. However, for longitudinal waves, we don't have that opportunity because the oscillation alignment for a longitudinal wave particle is same / parallel with the direction of the energy flow, which means you basically all the particles are all aligned in the same straight line. They're moving back and forth, but their alignment cannot be different. They're all practically parallel to each other. So you basically have one single alignment for all the particle vibration, and that single alignment is by all means it is the alignment it is the direction of the energy flow. That's why longitudinal waves can never be polarized. However, only transverse waves can be polarized. So if you look at the other options for option number 5, it says that sound can be reflected from a solid surface. Sound cannot be polarized. Sound is diffracted around corners. Sound is refracted as it passes from hot air to cold air. Okay, actually this behavior don't prove that it is a longitudinal wave. The property which proves it is a longitudinal wave is that sound waves cannot be polarized. That's the important bit. আচ্ছা এরপরে কোশ্চেনটা আমরা দেখব এই কোশ্চেনটা বেশ important because it has a lot of variables to deal with. So I'm going to help you solve this question number 6. Have a look. A plane wave of amplitude A is incident on a surface area S placed so that it is perpendicular to the direction of travel of the wave. The energy per unit time reaching the surface is E. The amplitude of the wave is increased to 2A and the area of the surface is reduced to half S. How much energy per unit time reaches the smaller surface. আচ্ছা আমরা এই কোশ্চেনটার কন্টেন্টটাকে ভালো করে বোঝার চেষ্টা করি. The first thing we need to remember that intensity of a certain wave means power per area. Power per area means amount of energy per second falling on per unit area is defined as the intensity of that surface, intensity received by that surface at that instant. So এখান থেকে আমাদেরকে এই ভ্যারিয়েবল গুলোকে সামহাউ নিয়ে ম্যানেজ করতে হবে. So কোশ্চেনে খেয়াল করি, a plane wave of amplitude A is incident on a surface of area of S plus so that is perpendicular to the direction of the parabola wave. The energy per unit time reaching the surface is E. So for this question, the surface area has a value of S and the power received by the surface is E. So if you think about it, intensity would be E by S because intensity is given by power by area. এটা একটু সবাই কপিতে লিখো because I cannot very acha maybe I let me try see I'll try to find out whether I can also switch back and forth. Okay, this is a bit weird. No. Okay, I want to move from here to share a white screen. So how do I share a white screen from here? More meeting settings. Can you see that I'm going in the meeting setting menu?
Yes, sir.
Yes, sir.
So you can practically see everything that I'm everywhere I'm going.
Yes, sir.
স্যার ডোন্ট আমরা ভালো মানুষ
Cool. And it's also on record, so I should not do weird stuffs. Okay. Key point to remember, shouldn't forget this. There was an option that I could also share the কি বলে a whiteboard.
স্যার অ্যানোশনের চেষ্টা করেন
মোড়ে গেলাম, এতে রেকর্ডিং দেখাচ্ছে, চ্যাট দেখাচ্ছে, ডিসকানেক্ট অডিও, মিটিং সেটিংস, আর তো কোনো অপশন এখানে নাই. আচ্ছা দাঁড়াও, জুমের উপরে ক্লিক করলে তো আরো অপশন আসে, এই যে এখানে চাপ যেমন আসবে. ও না, এটা তো জুমের ইনফরমেশন. Wait, just a second. Stop sharing, change sharing. What if I start video? Okay. Can you see only my face or the entire screen with my face at the corner?
Everything, sir.
Entire screen with your face in the corner.
So you can see the entire screen with the face with my face in the corner. Okay.
Yes, sir.
So it's an entirely new thing. I mean, I'm practically figuring out Zoom firsthand for a mobile. So please bear with me.
স্যার নো প্রবলেম আপনি সময় নেন আমরা আছি
Okay. If I now stop the video, then I'm sharing my screen. And then if I go to, Acha, what if I stop sharing? Will the recording get stopped? I don't think so. Yes, I have to stop sharing and then I can go into, and that's not a very pragmatic thing to do. Never mind. It's still under recording, but you cannot see anything because I'm not sharing anything. Okay, I'll share the screen once again. Okay. So I have started the screen sharing once again. I just need to find out a blank space where I can write and draw stuffs. Do we have that kind of thing in MiFone? Like a basic draw tool? Recorder, download, me, remote, share, me, scanner, FM radio, screen recorder, gallery. I have resumed the recording. So going back to just a quick just a quick recap of the question. The question that we are at, it said that uh, a wave of amplitude A is incident on the surface of area S that is placed so that it is perpendicular to the direction of the travel of the wave. So important information to understand. Important information to understand is that we are allowing E amount of energy every second on the surface that has a surface area of S. And that wave which is causing this to happen has its own amplitude of value A. So we're gonna use this information. First, just keep this information in shape, and then I'm gonna take the second set of information. So if I'm just switch the app, go to live board. Here I am. So for the first case, this wave I can be written as E divided by S. This is the equation for intensity formula, power by area. And we have to remember that this I was supplied from an amplitude of A only. So I'm just এটাকে এখানে আলাদাভাবে লিখলাম because I am not gonna write I proportional to A square because that might actually confuse. Just remember that this energy is being supplied from using a wave that has an amplitude of A. The next part of the equation says I have to exit. Okay. The next part it says that the amplitude of the wave is increased to 2A and the area of the surface is reduced to half S. How much energy per unit time reaches this smaller surface? So amplitude is made to 2A, which means amplitude has been doubled, and the surface area is reduced to half S. So, and how much energy per unit time reaches to this some smaller surface? And again, I'm going to take a break to how much energy is coming out. So we are going to take help of the energy. So first thing that we're going to try to do is let's try to understand. For the second wave, for the second scenario, the intensity, let's say the new intensity, I'm going to write this as first wave. So this is I1. For the second wave, the new intensity is going to be E2 divided by half S. Now, we are trying to find out what is the value of this E2 because the question is asking us that what is the amount of energy falling onto the screen for every second. So this is basically our question mark. So this is the question mark that we have. So somehow, if we want to relate this to equation, we have to find out the ratio of I1 by I2 because you have a look. If I now just simply divide these two equation, I'm going to have on the left side I1 divided by I2, which is a ratio that I have to work with, and S will be cut off. So we're going to have a numerical constant half at the bottom. And in that way, we can express the E2 in terms of E. So if I do that division, so let's say I'm going to give a mark over here. If I just do the division over here, I'm writing all these stuffs with my index finger. So it's a bit clumsy. I don't have a touch device or touch or pen kind of thing. Might as well actually arrange that if I want to take more classes in my phone. But if you have difficulty reading my handwriting, please let me know. We know that the intensity is there. Yes, amazing. They made an amazing job. So we know that intensity of any wave is given by I proportional to A squared. That's the basic relationship. So if I write the ratio that I1 divided by I2, that can be written as A1 squared divided by A2 squared. So this is a basic idea. And in the question it says that whenever we shifted for the second wave, it was given an amplitude of 2A. So for the first wave, the amplitude was A, which was increased to 2A. So let's remember this information because we are now going to replace this value. So let's add another page. What is this? Let's add another page, buddy. Very first. And the same page. So if I go ahead and write this value, so now I1 divided by I2. So I1 can be written as proportional to A squared. I shouldn't write A1, so I'm going to use that. And I2 should be proportional to 2a whole squared. So now we can see that the I1 by I2, this ratio is gonna become 1 by 4. So this is the basic idea. So this is the core ratio of 1 by 4. So if you have a look over here in the first place, we had in the ratio, hold up. Okay, so we can see that I1 by I2, yeah, we had this whole thing, this entire thing. So if we now do a bit of a division for these two parts, for those of you who are doing your class from the computer, is this whole writing covering your entire screen?
Yes, sir.
Like the
Yes, sir.
entire of the screen, like the whole the full monitor?
Yes, sir. Almost all of it.
Shit, I look like a monster.
কেমন স্যার?
Because I'm writing so big, but practically I'm writing the smallest I can. So now, acha, never mind. Now what I'm gonna do, I'm gonna try to divide these two equations. This one, this first one, I'm gonna divide this with this one. So have a look at the equation because I cannot show you to them very easily multiple screens. So let's take another page. No, actually, never mind. So if I just try to divide this, actually, okay. So I1 এই হচ্ছে ইকুয়েশনের অবস্থা। তো এখান থেকে আমাদের এস আর এস ক্রস আউট হবে, সো হাফটা চলে আসবে নিচে। সো এইটুকু তোমরা একটু কপিতে লিখো, আই রিয়েলি ডোন্ট ওয়ান্ট টু রাইট ইন দিস ফরম্যাট টু মাচ, and then replace the I1 by I2 ratio as 1 by 4 because that's what I showed on page number 3. So in this page, so that the ratio of I1 by I2 is 1 by 4. So replace this I1 by I2 as 1 by 4 and then ultimately calculate out E2 equals to some number. I don't know what that is. I want you to find this out. Multiplied by E. এই নাম্বারটা কত হয় এটা হিসাব করে বাই করো। Help yourself, everyone. করে দেখো এটা কত আসে। কত আসছে?
2 আসে কি?
2 আসে?
Yes, sir.
আচ্ছা, একটু এই এমসিকিউ পেপারে মার্ক স্কিমটা দেখো তো, যেটা ফার্স্ট বুকলেটে দেওয়া ছিল, যে এটার কারেক্ট আনসার কি 2 কিনা। হ্যাঁ,
বি হবে।
কারেক্ট আনসার 2।
মানে হ্যাঁ, বি।
স্যার মার্কস মে বি দেওয়া।
বিউটিফুল, ঠিক আছে, ঠিক আছে, বিউটিফুল। আচ্ছা, আমরা তাহলে এরপরের কোশ্চেনটা দেখি। ভালো, just a second. I would like to mute myself. I don't know how to do that. Okay. Don't listen to me for the next couple of things. তোমার কি হেডফোন আছে? না, হেডফোন আছে, দিয়ে যাও হেডফোন ইউজ করে। All right. So let's have a look at the next questions. What do not travel speed of light in vacuum? This is not a আচ্ছা, এই যে কোশ্চেন নাম্বার 9টা আছে, এই কোশ্চেন নাম্বার 9টা হচ্ছে একটা দরকারি কোশ্চেন। থ্যাংক ইউ। কোশ্চেন নাম্বার 9টা হচ্ছে একটা দরকারি কোশ্চেন। তোমাদের একটা জিনিস খেয়াল রাখতে হবে যে in our O levels we had to learn, memorize, or however you say it, the sequence of the electromagnetic spectrum of different parts of it. The sequence of the electromagnetic spectrum of different parts of it. However, in our AS level, we have to, additional to that, we have to remember a typical set of values for that thing. I don't have that. I don't have the book PDF with me right now. But if you turn up in your course book in the Waves chapter, in one of the pages you'll find a small table where they have given you some sample values of wavelengths of or frequency of the 7 different segments of the electromagnetic spectrum. For example, gamma, X-ray, UV, visible light, then the infrared, microwave, and radio wave. You have to memorize at least one column of it. Memorize. I mean it. That you have to. If you memorize the wavelengths, you can find out the frequency from d equals to f lambda. Or if you memorize the frequencies, you can get with the wavelength. This is important because this is a capability that the CAE asks for the students to have. So this question that you see over here, which is question number 9, is from the concept of that question. I'll help you to solve it. Have a look. It says the number of wavelengths of visible light in 1 meter of in the order of how many, which is basically asking you that how many wavelengths of visible light exist in 1 meter length. Now you can only know that, or you can only calculate that if you know a sample value of the wavelength of visible light, any part of the visible light you take. Now I know for a fact that the visible light wavelength is actually from 4 into 10 to the minus 7 to 7 into 10 to the 7 meter. This is something that I know because I've been teaching physics for a pretty long time. My brain picked this up. So that's the typical range for the visible light spectrum. So 4 into 10 to the minus 7 is the smallest wavelength, which means this is for the purple violet color, and 7 into 10 to the 7 is the longest wavelength for the visual spectrum, which means this would be on the red side. So আমার কথা শোনা যাচ্ছে?
Yes, sir.
Acha. So this will be existing on the red side. So if I take about a halfway value, if you do the average of these two things, let's say 4 and 7, let's say if you want to take 5 or 6, any of this value, take a halfway value, maybe 6. So if you assume that typical value for a visible light wavelength is 6 into 10 to the power minus 7 meter, that is exactly the length of one wavelength. You want to find out how many of these will exist in 1 meter. So you just divide by that ratio. So 1 divided by 6 into 10 to the power minus 7. এটা একটু করে দেখো কত আসে। 1 divided by 6 into 10 to the power minus 7. এটা করলে কত আসে?
1.6 into
So
10
1.6.
1.7 into 10 to the power 6.
1.6 into 10 to the power
1.7 into 10 to the power 6.
1.7 into the 6. Beautiful. So a 1.72 actually আমাদের লাগবে না because that's the first digit for our standard form. এই যে 10 to the power 7 যে ভ্যালুটা আসছে, this is basically what we are after. Whenever the question says that the number of wavelengths of visible light in 1 meter is in the order of means if you get that number, what would be the 10th multiplier of that number is. So এখানে আমাদের 10th multiplier আসছে 10 to the power 6, তাই না?
Yes, sir.
Yes, sir.
So B is the correct response. বুঝা গেছে কিনা?
G, sir.
Yes, sir.
ঠিক আছে? সো এটা এখানে ভিজিবল লাইটের জন্য বলছে, এটা গামার জন্য বলতে পারে, এটা এক্স এর জন্য বলতে পারে, অনেক কিছুর জন্য বলতে। You do not have in your memory the typical set of values for those specific set of the range of the electromagnetic spectrum, you won't be able to answer this question very easily. You have to remember those things / memorize, however you put it. So look up that table. I don't have those values memorized because I don't have to, but I always tell the students that they have to. So look up the table, write it up in a piece of paper, keep it somewhere on your table or under the glass of your table. Keep it somewhere around your study corner so that you can every once in a while look at this table and you can refresh your memories about it. That's basically how we remember stuff, by repetition, by revising. So just write it somewhere and make it visible to your eyes so that every once in a while you can take a look and so that you can easily remember it. It really helps. Although it sounds a bit nerdy, but it actually helps. Number 10 তোমরা পারবা। নাম্বার 10 আমি তোমাদেরকে থিওরি পড়ানোর সময় আলাপ করছিলাম। অ্যাকচুয়ালি থিওরি পড়ানোর সময় না, আমরা যখন পেপার 2 সলভ করছি তখন বলছিলাম যে change of amplitude affects intensity in square format, in square ratio, but on the vice versa, change of intensity affects the amplitude in root over ratio. So in this case, the I was changed into 2i. So essentially, the amplitude should be changed from A into root over of 2a. So B is the correct response. Number 12 টা একটু ট্রাই করো everyone. Number 12 টা একটু ট্রাই করে দেখো কি আসে। This nut mode is actually really good. Makes it even more visible, right? তাই না?
It does.
Yes, sir.
কিছুটা হ্যাঁ স্যার।
আচ্ছা তোমার কি আমার কথা শুনছো? Because I just plugged in a microphone, sorry, a headphone, and I have put my. Can you please hear me still?
Yes sir.
Very clear.
But the sound is still coming out from my phone's speaker. So maybe the microphone jack is not detected or the Zoom is allowing it to override. I'm not sure about that. Acha, as long as you can hear me, I'm good. No big deal. So number 12. The question says the frequency of a certain wave is 500 hertz and its speed is 340 meters per second. What is the phase difference between the motion of 2 points on the wave which are 0.17 meter apart? So you are trying to find out the phase difference with the length information. So remember that very useful information that I gave you, that lambda relates to 360 degree. 360 degree basically means 2 pi, which also relates to what? Time period, which also relates to 4a amount of distance covered by one of the oscillating particles. So there, this is a 4-part information. So 1 lambda is relevant to 2 pi radian. বুঝছো? So এখানে তুমি এখন বের করবা আমাদের ফার্স্ট যে দুটো ইকুয়েশন আছে v equals to f lambda দিয়ে বের করে যে এই ওয়েভের ওয়েভলেন্থ কত আসে। ফাইন্ড ইট আউট, কত আসে? v equals to f lambda দিয়ে ওয়েভলেন্থটা বের করো।
Sir 1.47.
এত বড় আসার কথা তো না,
0.68
0.68 আসার কথা। v equals to f lambda, 340 equals to 500 into lambda. 340 divided by 500 করলে কত আসে? That's the question. ফায়াজ মনে হয় রেশিওটা উল্টো করে ফেলছো, 0.68 হবে। তুমি উল্টো করে ফেলছো ঠিক না?
হ্যাঁ স্যার একটু বলেছেন।
আচ্ছা সমস্যা নেই। Be careful of your mistake. হ্যাঁ সমস্যা নেই। Be careful of your mistake so that এটা পরে যাতে না হয়, এক্সামের সময় যাতে না হয়। Just remember that it should be avoided. আচ্ছা, সো আমাদের ওয়েভলেন্থ আছে 0.68। এখন তুমি বেসিক ইউনিটের মেথড অ্যাপ্লাই করো। 0.68 অ্যারো দাও, লেখো হচ্ছে 2 পাই। সো 1 এ কত হবে, 0.17 এ কত হবে, হিসাব করে বাই করো এটা কত আসে, পায়ের টার্মসে কত আসে। কত আসছে?
0.55
0.5
B.
পাই মানে পাই বাই 2, পাই বাই 2, which means B is the correct response. বুঝা গেছে?
Yes.
জি স্যার।
আচ্ছা, এইটা অনেস্টলি স্পিকিং এটা আমাদেরকে কনভেনিয়েন্সের জন্য একটা মানে 0.17 is actually 1/4 of 0.68, সো ওই জন্য আমাদের একটা ভালো রেশিও আসছে। বাট for all practical reasons they might not give that this kind of value, they could give any random value. For example, if I asked you that what is the phase difference between the motion of 2 points on the wave which are, let's say, 0.20 meter apart, the question is exactly same, but if I replace that value by 0.20, how many radians would that be? in that case it will not be as beautiful as pi by 2. You're going to get a fraction value. Pi value বসায় সেই fraction value তোমার বাই করতে হবে. So give me the number of radian if these two particles were asked to were said to be 0.20 meter apart. From the same relationship, calculate the decimal value of radian. How many? What is the phase difference? কত আসে?
0.59 meters.
0.59 তারপর
588.
আচ্ছা 0.588 রেডিয়ান আসছে জারিফের। বাকি সবাই দেখো মিলছে কিনা, কনফার্ম মি।
জি স্যার আমার মিলছে।
সবাইকে বুঝছো প্রসেসটা কিরকম? দ্যাট রিলেশনশিপ অফ দ্য 4-part রিলেশনশিপ ল্যামডা, তারপর হচ্ছে 2 পাই রেডিয়ান 60 ডিগ্রি, অথবা হচ্ছে টাইম পিরিয়ড টি, অথবা হচ্ছে 4a ডিস্টেন্স। দিস রিলেশনশিপ ক্যান বি প্রুভ টু বি ভেরি ইউজফুল ইফ ইউ নো হাউ টু ইউজ ইট ফর অ্যাপ্রোপ্রিয়েট কেসেস। আচ্ছা এটা গেল, সরি। এরপর বলছে হচ্ছে সাউন্ড ওয়েভ নাম্বার 14 দেখতেছি আমি। Sound wave X has intensity 10 to the power 12 times greater than that of sound wave Y. By how much is the amplitude of X greater than the amplitude of Y? So you just have to root over this factor, so you get the actual. So root over of 10 to the 12 মানে কত হবে? 10 to the 12 into half, 10 to the 6. A is the correct response. Why is this an important question? Never mind. Which wave properties change when light passes from air into glass? Okay, this is the important bit. No matter what wave behavior, reflection, refraction, diffraction, polarization, doesn't matter. No matter what wave behavior any wave undergoes, its frequency will always remain constant. Frequency is a property of a wave which never changes by physical factors. It is a property of a wave which is exclusively dependent on the source. একটা ওয়েভ সোর্স থেকে একবার রিলিজ হয়ে গেছে মানে হচ্ছে তার ফ্রিকোয়েন্সি কোনোদিন চেঞ্জ হবে না। ওয়েভলেংথ এবং স্পিড অফ দ্য ওয়েভ এই দুইটা জিনিস ইন্টারডিপেন্ডেন্টলি চেঞ্জ হতে পারে। Because v equals to f lambda. F will remain a constant, v and lambda will change proportionally, which means এই ক্ষেত্রে আমাদের কারেক্ট রেসপন্স হবে হচ্ছে what properties change when the light passes from air into glass. কারেক্ট রেসপন্স হচ্ছে C. এখানে তারা কালার কথা ইউজ করছে। কালার অফ এ ওয়েভ অর ভিজিবল লাইট বেসিক্যালি রিপ্রেজেন্ট টু ইটস frequency. Monochromatic light means light of a single frequency, not light of a single wavelength, because a single color essentially means it is a wave of a single frequency.
স্যার নাম্বার 15 পড়লেন না এখানে?
হ্যাঁ এইমাত্র 15 নিয়ে আলাপ করলাম।
স্যার একটু বুঝাবেন, আবার আমি বুঝিনি।
শিওর। কি ইনফরমেশনটা হচ্ছে মানে যেটা মনে রাখতে হবে যে বেসিস অফ ফর সলভিং দিস কোশ্চেন ইজ দ্যাট একটা ওয়েভের যদি বেসিক তিনটা প্রপার্টি আমরা জাজ করি ফ্রম দ্য ইকুয়েশন v equals to f lambda, there is the speed of the wave, there is the frequency of the wave, and there is the wavelength of the wave. এই তিনটে প্রপার্টির মধ্যে একটা ওয়েভের ফ্রিকোয়েন্সি, the frequency of a wave is an unchangeable property of the wave. Once a wave is created and released from a source, no matter what you do to that wave, its frequency will always remain unchanged. So it might undergo reflection, it might undergo refraction, it might be dispersed, it might be diffracted, it might be polarized. These are the name of the multiple wave phenomenon that we actually handle. So no matter what you make this wave to go through, it will never undergo any change of frequency. So in the equation v equals to f lambda, try to visualize, or you can write it. In the equation v equals to f lambda, f will be a constant once a wave is produced from a source, which means v and lambda, these two will be directly proportional for a specific wave. So if in any medium the speed of the wave is less, then the lambda would be less. in the same proportion. If the speed is larger, then the lambda will be larger in the same proportion, and vice versa. বুঝছো?
Yes, sir.
আচ্ছা। So if we go to the next page, reflection of the given in relation to number 18. Number 18 কে আমরা আগে সলভ করছিলাম না মনে হয়। আচ্ছা, নাম্বার 18টা দেখো। Diagram 1 shows a ripple tank experiment in which plane waves are diffracted through a narrow slit in a metal sheet. Diagram 2 shows the same tank with a slit of greater width. Which action would cause the waves in diagram 1 to be diffracted less and so produce an emergent pattern closer to that shown in diagram 2? Which means that we are sending parallel flat waves from the vibrating bar. In diagram 1, we have kept the gap through which the diffraction is supposed to work in such a way that we are getting circular diffraction. Nice. And on the second one, the gap is apparently pretty large. So we are having flat wave coming out from the flat section. And on the corner of the, or on the exact border of the flat waves, we have a bit of bending outwards. So that's that. Now the question says over here, which action would cause the waves in diagram 1 to be diffracted less and so produce an emergent pattern closer to that shown in diagram 2? So বুঝার চেষ্টা করো যে আমরা কোনটাকে চেঞ্জ করে কি বানাতে যাচ্ছি। Do you want diagram 1 looking like diagram 2 or do you want diagram 2 looking like diagram 1? What do you want to achieve?
Sir, diagram 1 to diagram 2 এর মতো চাই।
Diagram 1 কে diagram 2 এর মতো করতে যাচ্ছি, which means we want the diagram 1 to not have circular wavefronts. We would rather appreciate the diagram 1. What change should be brought into the setup of diagram 1 so that its output waves look similar to that is available in diagram 2? So diagram 1 টাকে আমরা diagram 2 বানানোর জন্য কি করতে পারি? This is the question. So let's have a look. এখানে কোশ্চেন বলছে হচ্ছে আচ্ছা, before I going to tell you the answers, I want you guys to understand that to achieve this kind of wide wave output, there are multiple things that we can do. Have a look at diagram 1 and try to visualize. We can increase the gap size, which is very simple. That's one thing. Or if you don't want to change the gap size, we can make the incoming wavelengths, which means the gap between the wavefronts, the gap between each of these, gap between two consecutive of these parallel lines is actually one wavelength. So we can make the wavelength of the wave much smaller because we have this kind of flat wave coming out whenever the wavelength is significantly smaller than the gap size. In that case, we don't have circular diffraction, rather we have flat waves coming out. So diffraction only happens at the corner, at the borders of the waves. So there are two different things we can do. We can either increase the gap size or we can reduce the wavelength. কারণ আমরা যদি একই গ্যাপ সাইজে যদি ওয়েভলেন্থটাকে রিডিউস করে দেই, which means the waves would be produced really close to each other, and in that case the wavelength of the wave would be considerably smaller or significantly smaller compared to the gap size, which is going to lead to similar diffraction behavior like in diagram 2. So answer গুলোতে আমরা দেখি যে আমাদের কি কি দেওয়া আছে। এতে বলছে increasing the frequency of vibration of the bar. If you increase the frequency, what will happen to the wavelength? Wavelength কমে যাবে। and এটা কেন কমে যাবে সেটা বলতেছি। সেটা হচ্ছে here the wave is being produced on a single medium. We can change the frequency of the wave by our wish, and because this is the vibrating bar, which is usually operated by an electromagnetic vibration mechanism. So, but the medium through which the wave is passing by is kept the same, which is the water medium. So in this case, the speed of the water medium, speed of wave in the water medium, that will remain constant, which means V is a constant, So if we increase the value of f, lambda will become small because v goes to f lambda, which means for a constant value of v, the product of f and lambda has to be equal, which means if one goes up, the other one goes down. So they will be inversely proportional to each other. So if we increase the frequency of vibration of the bar, we're going to have reduced wavelength. So which seems like sounds like a correct response for our requirement for this question. So এটা হইতে পারে. Let's look at the other options and see what we can have. In the other options, it says that in number 17, in option just B, it says increasing the speed of the waves by making the water in the tank deeper. Increasing the speed of the waves by making the water in the tank deeper. If we make the water in the tank deeper, in the deeper medium, the waves travel faster. Do you guys know that?
Yes, sir.
Yes.
If you remember from the O levels, that shallow relates to slow. They have a bit similar spelling, and the other, which means deeper water, relates to faster wave. Now think about it. So if we make the water deeper, the speed of the wave will increase for the same frequency. So if we keep the frequency same, if the speed of the wave increases, then for the same frequency of the vibrating bar, the wavelength of the wheel will also increase. If the wavelength actually become increased, we are not going to have our desired effect, because we want the diagram 1 to become look like diagram 2. So we're not going to achieve the reduction of wavelength, rather that will lead to increase of wavelength, so which is not what we want to achieve. So B bad. C number, I will say reducing the amplitude of the vibration of the bar. Amplitude of the wave, amplitude of the vibration of the bar does not have anything to do with the frequency or the wavelength. So this is a totally unrelated factor that we're trying to change, which is not going to bring about any change in the shape of the figure. So C is just pakwas. D, I will say reducing the length of the vibrating bar. Reducing the length of the vibrating bar will simply cause these flat waves, which are released from the vibrating bar, to come and hit the gap and the walls. That size of the wave will become small, but the in between gap, which is wavelength or the frequency of the wave, these will all remain same, because the option just D is proposing the change of only one factor, not multiple factors. So this is also another thing that we have to understand, that এই জন্য এই জিনিসটা এখানে acceptable হবে না. বুঝা গেছে?
আরেকবার বলবেন।
But D point কি আরেকবার বলবেন?
D নাম্বার
Yes, sir.
কোনটা
Option D.
কোনটা?
Sir, option D.
আচ্ছা, বিটা বলছে হচ্ছে increasing the speed of the wave by making the water tank deeper.
Sir,
So
D.
আমার
আচ্ছা,
বি
ঢাকা।
লাগবে, এটা বলেন।
Yes, sir, ঢাকা.
আচ্ছা বি বলতেছি, বি এর পর আবার ডি বলবো, সমস্যা নাই. So you have to take the information that is given in the question to its word. To its word মানে হচ্ছে, if the question is proposing that we are going to bring about one change, you have to understand that we are only going to that change exclusively. We're not going to change the other variables involved. We're only exclusively going to bring that change. So when in option just B it says that we're going to increase the speed of the waves by making the water tank deeper, so we're only going to increase the speed. So we are not going to change the vibration frequency of the horizontal bar or vibrating bar. So think about it. In the equation V equals to F lambda, we're making the V large. F is a constant. We're making the V large. F is a constant. So essentially, what happens to your lambda? Increases, right?
Yes.
Lambda also increases. And কথা হচ্ছে, if in diagram 1 the lambda becomes larger, would we achieve our desired effect? Would it start to look like diagram 2, or it will still be circular? এই পার্টটাতে কনফিউশন হচ্ছে, রাইট?
Yes, sir.
আচ্ছা, ঠিক আছে, I'll help you to understand it better. সেটা হচ্ছে, we only have circular diffraction as shown in the diagram 1. We only have circular diffraction whenever the gap size is almost equal to the wavelength. If wavelength is too large, we are going to have, if the wavelength is too large and the gap is too small, then we are still going to have circular diffraction, but the angle of spread, I mean the arc size of those waves which are coming out, that will be very small because we are not allowing too much energy to pass through. This is when the gap is small and wavelength is too big. On the other hand, if the gap is too big and the wavelength is too small, we're going to have a situation like diagram 2. So to achieve a situation of diagram 2, we need to make sure that we are looking forward to have a large gap with small wavelength. Large gap with small wavelength. So compared to itself. Now in option choice B, it says that we're not going to alter anything except for the speed of the wave, which means we're going to increase the speed of the wave, keep the gap size same. So whenever we're increasing the speed of the wave, our wavelength is becoming larger, which means our gap size remains the same. So now the wavelength has become significantly bigger compared to the gap size. This will not lead to the shape of diagram 2. Rather, this will simply give us circular wavefronts with smaller arc length. বুঝা গেছে?
Yes, sir. বুঝতে পেরেছি।
Sure. আচ্ছা, ডি নাম্বারটা বলতেছি। ডি নাম্বার বলছে reducing the length of the vibrating bar. Reducing the length of the vibrating bar will simply make, এখানে দেখো আমাদের vibrating bar এর থেকে কিছু দূরে আমাদের যে কিছু parallel waves, there are some straight parallel lines on the left of the gap and the barrier, which is representing the incoming waves which are about to hit the gap, and then they are gonna undergo diffraction. So আমরা যদি vibrating bar লেংথটা কমায় দেই, simply আমাদের ওই incoming wavefronts গুলোর লেংথটা কমে যাবে. As long as the wavefronts are long enough to cover the gap, the total amount of the gap, you can produce diffraction, no question asked. So if you reduce the length of the vibrating bar, it will become small, and we will be slowly losing the shape of the, let's say, the of parallel lines, but we'll still have waves produced from the vibrating bar, and they will still be hitting the gap at the same frequency and wavelength. So the rate at which energies are gonna be received, or the waves which will hit and pass through the gap, they will have pretty much the identical property. Simply the shape of the wave on the left side of the barrier, that will have a different shape because of the length shortening of the vibrating bar. That's the effect you're going to have. But on the right side, that behavior will remain pretty much unchanged. বুঝে কি বলছি?
Yes, sir. Thank you, sir.
Yes, sir.
No problem. আচ্ছা, এরপর বলছে
Sir, 19
Number
is
9.
হবে না কেন?
আচ্ছা, 19 দেখছি. Which statement about sound waves in air at constant temperature is correct? আচ্ছা, Pawan, just a second. I have to. I'll be right back. Hold on a second. 19টা একটু পড়ো, পড়ে একটু ট্রাই করো, বুঝার চেষ্টা করো। All right, I'm back. Question 19 will say which statement about the sound waves in air at constant temperature is correct? Amplitude is inversely proportional to velocity. There is no such relationship that we know that satisfies this this statement. Frequency is inversely proportional to wavelength. This actually sounds correct. I'll tell you why. The speed of sound in air depends upon multiple properties of that air. One of those properties is temperature. At hot temperature, we have at hot air. In hot air, we have one type of speed, faster speed, because the air particles actually can move around at a higher speed because the high temperature, so they can transfer the vibrations from one particle to the neighboring particle faster, which increases the speed of the sound, and vice versa for the other part. এটা একটা আর এটা হচ্ছে যে এটা হচ্ছে একটা factor. The second factor that affects is the humidity. Humidity is basically about how much water vapor a certain amount of air can contain. So whenever any air is humid, its particle density per volume of air is more compared to dry air. Dry air per volume তোমার যতগুলো particle থাকবে, particle বলতে আমি এখানে all of the gaseous molecule that is present in a certain amount of air meaning করছি. For example, nitrogen molecule, carbon dioxide molecule, oxygen molecule, water molecule, all of them, and microscopic dust particles, everything. Microscopic dust particles. So whenever sound will essentially pass through, if there are bigger number of particles, the transfer of the energy can happen faster. So humidity is one factor, and temperature is also another factor. So when the temperature of air is kept constant, then it can actually, when the temperature of the air is kept constant, when the temperature of the air is kept constant, it can actually make the water, it can make the sound energy, speed of the sound constant. So if you consider the equation V equals to F lambda, just write it or just visualize it. V is a constant and equals to F lambda, which means whatever value that you choose of F and lambda, the product of these two variables should be directly inversely proportional to each other, should be same, which means they're inversely proportional. So that's why B is the correct response. C will say velocity is proportional to wavelength. Velocity is proportional to wavelength essentially means frequency is constant. At constant temperature, velocity is not proportional to wavelength. If you use a certain at constant temperature, velocity proportional to wavelength means if you can somehow produce sound waves of higher wavelength, you'll have bigger velocity. If you can somehow produce sound waves with lower wavelength, you'll have a lower velocity. But that's not the case. That's not the case at all, because when at constant temperature of air, the speed of sound is practically constant. The two things that can vary is frequency and wavelength, which means if you set up sound waves from multiple different frequency sources, all of their wavelengths would be produced in such a way so the product of frequency and lambda, these two variables always give you a fixed number. So C is not correct. D তে বলছে wavelength is proportional to amplitude. This is also not correct at all. Wavelength doesn't have anything to do with amplitude. Amplitude is essentially related to intensity, and amplitude can also affect in the calculation for superposition or interference, but it doesn't have anything to do with wavelength. So altogether, B is the correct response. ইফাত তুমি কোন অপশনটা নিয়ে কনফিউজ ছিল বলছিলা?
সি বুঝছি।
আচ্ছা, সো 20 তোমরা ট্রাই করলে পারবা। 21 ও সিমিলার কোশ্চেন আগে পড়েছি আমরা। আচ্ছা, এখানে আমি একটা সিম্পল জিনিস তোমাদেরকে একটু বলি। নাম্বার 24টা একটু দেখো। 24 is a pretty simple but interesting question. This is a surface device emits laser pulse. What is the time taken for the pulse to travel from the device to a wall 150 meter away where it is reflected and then return to the device? এই কথাটার মানে কি? এই কথাটা একটু বোঝার চেষ্টা করি। সেটা হচ্ছে surveyor is using a device using a laser pulse. Laser pulse means it has an electromagnetic wave, which means the speed of the wave is all right. Are you hearing music?
Yes, sir.
Very cool.
Someone having some sort of party around the location that I am. Acha, let me finish the discussion of at least this question, and then I'll pause it and relocate myself to a quieter place. So, এটা হচ্ছে the wave that he is using is essentially a laser pulse, which means it's an electromagnetic wave. So, because it's an electromagnetic wave, its speed is known to you, 300 meter per second. That's one thing. The other thing that you really need to remember from your all of this part, that whenever we do echo method, it means we measure some distance, we do some experiment where a certain wave starts from the source, travels to a reflector wall, and then comes back to the source. In that case, the total distance is covers for the entire going back and forth is double the distance between the source and the reflector wall. So 2D. So in case of reflections, the equation for speed is given by V goes to 2D by T. That's the important bit that I want you to remember, because the question is asking us that what is the time taken for the pulse to travel from the device to a wall 150 meter away where it is reflected and then return to the device. So to make this total journey, the light has to cover 150 into 2 meters, double of 150 meters. So just write up that equation and calculate this out for yourself. V goes to 2D by T, replace the V by 3 into 10 to the power 8 meter per second and D as 150 and calculate the value of T. Calculate করে দেখা কত আসে. And then in the meantime, I'll replace myself.
So you're going to be -6 seconds.
Sir,
Better. করছো এটা? কত আসছে?
Yes, sir.
হ্যালো,
হ্যাঁ স্যার।
শোনাচ্ছে?
হ্যাঁ স্যার, শোনা যাচ্ছে।
Why can't I hear you kids?
hello, sir.
আমার তো microphone. What? Holy crap. Somehow my আচ্ছা দাঁড়াও ঠিক করতেছে। Somehow my sound output has shifted to the small speaker that is used while making calls, not my original speakers. Hello?
হ্যাঁ স্যার শুনতে পাচ্ছি।
হ্যাঁ হ্যাঁ হ্যাঁ, এখন ঠিক আছে। সো এটা আনসার কত আসছে? 24 এর আনসারটা কত আসছে?
স্যার একটু দাঁড়ান।
1 and 10 to the power minus 6.
1 10 to the power minus 6 মানে 10 to the power minus 6 মানে হচ্ছে মাইক্রো, তার মানে 1 microsecond. This is the correct response from one of your classmates. দেখো বাকি সবাই ম্যাচ করে কিনা দেখো। ম্যাচ করছে?
ইয়েস স্যার।
আচ্ছা ওটা হয়ে গেলে 27টা ট্রাই করো। থ্যাংক ইউ। 27টা ট্রাই করো। কোশ্চেনটা পড়ো, see if you can make sense out of it. If you can't, I'll help you. At least বুঝতে হবে, this figure on the right of this question is showing you a still picture of a continuous diffraction behavior. So flat waves are coming in from the left, which is gonna pass through the gap and gonna become circular. So continuously এটা হচ্ছে, তার মধ্যে একটা snapshot না হয়েছে, picture না হয়েছে, so you are being shown that, which means the gap between consecutive wave fronts is wavelength. So এই জিনিসটা মাথায় রাখো and try to solve this one. So XY ওয়েভটা P পয়েন্টে রিচ করতে কতটুকু টাইম লাগবে? ইয়া ঠিক আছে, খাবার যা দিছিল সব খেয়ে ফেলছে না? আরেকটু চালু করছো আবার? ঠিক আছে ঠিক আছে ঠিক আছে। এটা যে হ্যাঁ বলছে সকালে কখন? আচ্ছা আমি আসছি, সমস্যা নাই। সো XY ওয়েভটা P পয়েন্ট পর্যন্ত রিচ করতে কয় ওয়েভলেংথ ডিসটেন্স কভার করতে হবে এটাকে চিন্তা করো। Give it a count through the gap. How many wavelength distance does the XY wavefront has to cover to reach to the wavefront that is located about point P? বুঝতেছো কি বলছি? I'll say it again. How many wavelength distance does the XY wavefront have to pass through the gap to reach to the position of the point P? How many wavelengths have to be passed?
3.
1, 2, 3, 4, 100, what?
3.
3.
The correct response is 3. It has to cover 3 lambda amount of distance. Now recall from the relationship that I told you that 3 lambda amount of distance cover requires 3 times time period. So এখানে আমাদেরকে বলছে at what time will some portion of the wavefront XY reach point P? So point P তে reach করার জন্য আমাদের 3 times the time period টাইম লাগবে। সো এখন তুমি গিভেন ইনফরমেশন গুলো থেকে হিসাব করে বাইর করো যে তোমার একটা টাইম পিরিয়ড কত হয়। আমাদের কোশ্চেন কি কি দেওয়া আছে? সি দেওয়া আছে, ল্যামডা দেওয়া আছে। তো সি ইকুয়ালস টু এফ ল্যামডা, এফ ইকুয়ালস টু 1 বাই টাইম পিরিয়ড। 1 থেকে টাইম পিরিয়ডকে সাবজেক্ট করে টাইম পিরিয়ডটাকে আগে বের করো কত হয়। 3 টাইমস দ্যাট ভ্যালু ইজ ইওর কারেক্ট রেসপন্স। কত আসবে?
সো সি আসে।
স্যার
সি আসে।
আচ্ছা, সি ইজ দ্য কারেক্ট রেসপন্স, বাট এটা বুঝছো কিনা সবাই? ইম্পর্টেন্ট
Yes.
পার্টটা হচ্ছে টু অ্যাপ্রিশিয়েট দ্য ইনফরমেশন দ্যাট physically the xy wavefront has to cover a length of 3 lambda to reach to the point P. এটা বুঝলে বাকিটুকু করা সিম্পল। এই যে দেখো নাম্বার 28 এ আমাদেরকে এক্সাক্টলি ওই কোশ্চেনটা করছে, which value is a possible wavelength of radiation in the microwave region of the determinate spectrum. So unless you memorize the table, there is no way you can answer this question. You might have to guess, or you might get lucky in your guessing, but if you know for a fact that you answer this question right, you have to memorize the table. So please do that. Please do that. আচ্ছা, এরপর আছে হচ্ছে 29। দেখতেছি আমি কোন কোশ্চেনটা করা হবে। আচ্ছা, আমি 35টা নিয়ে একটু আলাপ করি। Although 35 is a pretty simple question, but I'm gonna discuss this question so that it's easier for you to solve. Question 35টা দেখো, a sound wave of frequency 150 hertz travels in air in water at a speed of 1500 meter per second. It then travels through the surface of the water and into air, where the speed is 300 meter per second. Which line in the table gives the correct values of the for the wavelengths of the sound in water and in air? আচ্ছা, এখানে মনে রাখার জন্য সবচেয়ে ভালো বুদ্ধি হচ্ছে just write up some equation. Let me just write up some equation to show you what I'm trying to represent. So let me just take a new page. Beautiful. So একটা জিনিস খেয়াল করো। আচ্ছা, এই আঙ্গুলটা দিয়ে কি করে? বোর্ড মুভ করানো যায়? What does this finger do? আচ্ছা, to show something other than writing. আচ্ছা, okay. This one is for, wow, cool. This is nice. আচ্ছা, দেখাচ্ছি। I want to get rid of this. So what I'm trying to show you is, consider the equation. This is a single frequency sound that is going to travel from light into to na মানে কি বলে water into air. So এই কোশ্চেনে আমাদের ফ্রিকোয়েন্সি ভ্যালুটা দেওয়া আছে। ফ্রিকোয়েন্সি ভ্যালু দেওয়া থাকার জন্য আনসার দিস কোশ্চেন ইজ অ্যাকচুয়ালি প্রিটি সিম্পল, বিকজ ভি ইজ টু ল্যামডা। তুমি জাস্ট ডিফারেন্ট টেবিলে ডিফারেন্ট পার্টস থেকে ল্যামডা নিয়ে ফ্রিকোয়েন্সির সাথে মাল্টিপ্লাই করে চেক করে দেখতে পারবা যে আমাদের ওয়াটারের স্পিড ম্যাচ করতেছে কিনা, একটা হচ্ছে আমাদের এয়ার স্পিড ম্যাচ করতেছে কিনা। সো দিস ইজ ভেরি সিম্পল টু ডু, ইটস বেসিক ম্যাথমেটিক্স। What if this question, this exact same question was asked to you without mentioning the value of frequency? Same question is given, but সাউন্ডের ফ্রিকোয়েন্সিটা দেওয়া নাই, তখন তুমি আনসারটা কিভাবে করতা? কোশ্চেনটা কি বুঝতেছো?
Yes, sir. Force by lambda is equal to force 2 by lambda 2. ওইটা না?
ফোর্স না, স্পিড।
আচ্ছা, speed, sorry.
Sure. So জারিফ যেটা বলছে সেটা আমি দেখা যাচ্ছে, এটা হচ্ছে because it is the sound of a single frequency and frequency never changes. So I can write this that speed in water, let's say W, equals to frequency of the wave, which is unchanged, into lambda of water. Similarly, you can write speed in air equals to frequency into lambda in air. So আমি যদি এখন এই দুটি ইকুয়েশনকে ডিভাইড করে দেই, ফ্রিকোয়েন্সি বাদ, সো আলটিমেটলি আমরা কি পাবো? আলটিমেটলি আমরা পাবো হচ্ছে আলটিমেটলি পাবো হচ্ছে speed in air divided by speed in water should be equals to, actually উল্টা লিখে ফেলছি, দাঁড়াও, speed in water divided by speed in air should be equals to lambda of water divided by lambda of air. এই রেশিওটা সেম হতে হবে। সো কোশ্চেনে আমাদের এই দুইটা স্পিড দেওয়া আছে। আমাদের ওয়াটার স্পিড দেওয়া আছে 1500 মিটার পার সেকেন্ড আর এয়ার স্পিড দেওয়া আছে কত? এয়ার স্পিড কত দেওয়া ছিল? এয়ার স্পিড দেওয়া ছিল হচ্ছে 300 meter per second. So the ratio of these two values gives you 5. It means for these option choice, the ratio of wavelength in water divided by wavelength in air, a ratio to perfectly 5 হইতে হবে. So having a look at all of these options, which one of these option gives you 5?
Sir, D.
No. Wavelength of water divided by wavelength of air হচ্ছে 5 হবে।
ও আচ্ছা আচ্ছা স্যার wait.
So any value of the left column divided by same row value of the right column, that division should give you 5. So কোন রো এর জন্য এটা স্যাটিসফাই হয়?
Sir, C.
C এর জন্য এটা স্যাটিসফাই হয়। 10 divided by 2 gives you 5, which means C can be the correct response. This is the important bit that I want to show you, that frequency value যদি দেওয়া না থাকতো তখন আমাদেরকে রেশিও ইউজ করে চেক করতে হতো, and that is also a very valid and logical question. Frequency value দেওয়া থাকলে solving the problem becomes much too easier, which is obvious. But if the frequency value is not mentioned in the question, you should still be able to solve the question because it's not unsolvable. আচ্ছা, এটা গেল।
Three 37 এটা করবেন
37, sure, I can help. Continuous water waves are diffracted through a gap in a barrier in a ripple tank. Continuous water waves are diffracted through a gap in a barrier in a ripple tank. Which change will cause the diffraction of the waves to increase? আচ্ছা, diffraction increase কথাটার মানে বুঝি আমরা। Diffraction increase কথাটার মানে হচ্ছে the angle at which the diffraction happens, or you can say the arc length of the diffracted wavefronts, this will become larger, or the diffraction will happen for a much bigger angle, which means as the wave is gonna travel straight through the gap, they are gonna bend a lot. So the maximum bend direction for the wave would be bigger, or in other words, you can say the arc length would be larger. So if you want to achieve this behavior, if you want to have a large amount of diffraction, we essentially need the gap size to be nearly equal to the wavelength. We need the gap size to be nearly equal to the wavelength. এটা যদি অ্যাচিভ করা যায় তাহলে আমরা এটা পাবো। এখন গ্যাপ সাইজ নিয়ারলি ইকুয়াল করার জন্য অ্যাপ্লিকেবল অপশন কোনটা দেওয়া আছে সেটা খেয়াল করি। গ্যাপ সাইজ নিয়ারলি ইকুয়াল টু ওয়েভলেংথ ইজ অ্যাচিভেবল বাই হুইচ অফ দিস আনসার চয়েসেস সেটা আমরা অবজার্ভ করব। সো হ্যাভ লুক। এতে বলছে ইনক্রিজিং দ্য ফ্রিকোয়েন্সি অফ দ্য ওয়েভ। Increasing the width of the gap, reducing the wavelength of the waves, reducing the width of the gap. এটা তো ভেজাল কোশ্চেন হয়ে গেল। প্রবলেম হচ্ছে এখানে আমাদের স্টার্টিং কন্ডিশন বলে দেওয়া নাই যে কারেন্টলি আমাদের মানে ইফ দ্য কোশ্চেন had mentioned, if it did mention which it didn't, but let's say if it did mention to us that for a certain water wave. This is the scenario. So currently we have this. From this situation, if we want to get more diffraction, what do we need to do? যদি কোশ্চেনটা এরকম হতো তাহলে সলভ করাটা অনেক ইজিয়ার হতো, বাট এখানে কোশ্চেন আমাদেরকে ওটা বলে না। সো উই ডোন্ট হ্যাভ দ্য initial condition of the setup mentioned, so it is very difficult to go for a correct answer because we cannot say for sure what change should we do. I mean, is it the case for circular or circular wave, circular diffraction for a small angle?
স্যার আপনার কথা কেটে কেটে যাচ্ছে।
Yes, sir, আপনার কথা কেটে কেটে যাচ্ছে।
এটা কারেক্ট আনসার কি? হ্যালো,
Yes,
কারেক্ট আনসার কি দেওয়া আছে? বি দেওয়া।
ফর ঢাকা।
Reducing the width of the gap. But how can we say that? I mean, reducing the width of the gap will only give you the maximum or large amount of diffraction if and only if the that reduction if and only if that reduction of the gap ultimately makes the whole wave ultimately makes the gap length nearly equal to the wave. But এটা তো এখানে যে অ্যাচিভ হবে সেরকম কোনো ইন্ডিকেশন তো এখানে দেওয়া নাই। So how can I actually say that this is a correct response? I'm not exactly sure this the question of 37 is a fulfilling question, because if you ask me, unless we are given what the current situation is, we cannot actually tell what should be the process that we should follow, because we could achieve the greatest amount of diffraction either from a very small gap, a large wavelength scenario, or we could go the other way around. So এটা দুই দিক থেকেই অ্যাচিভ করা possible. So even if the answer just gives you 37 answer correct answer is D, I'm not very happy with the content of the question, if you ask me. In my opinion, there is just not enough information to make an informed choice. বুঝতে পারছি কেন? প্রধান,
Yes, sir.
জি স্যার।
so I'm going to leave it at that because there is not enough information. So if I even try to give you some reason that it answers to D হবে a reason, you can always actually baffle me that, but it's not mentioned in the question. How should you know this thing? Because I cannot tell you that you should know this thing out of thin air. It is not given in the question means you should not presume stuffs. Whatever information that you provide in the question, you should use that information towards achieving your answer, but which is not possible for this exact question. So might as well.
sir, D কোন কেসের জন্য কারেক্ট হইতো?
ডি কার্ড হয়তো বুঝো, ডি অপশন চেষ্টা বলছে হচ্ছে রিডিউসিং দ্য উইথ অফ দ্য গ্যাপ। রিডিউসিং দ্য উইথ অফ দ্য গ্যাপ যদি আমাদেরকে লার্জ অ্যামাউন্ট অফ ডিফ্রাকশন দেয়, তার মানে বুঝতে হবে যে ইনিশিয়ালি আমাদের ওয়েভ ফ্রন্টের শেপ ছিল মনে করা হচ্ছে যে ডায়াগ্রাম 2 এর মতো। এন্ড এই ডায়াগ্রাম 2 তে মনে করো যে সিচুয়েশনটা আছে, মনে করো ইনিশিয়ালি আমাদের ওয়েভ ফ্রন্ট ডিফ্রাকশন এরকম হচ্ছিল, আমি যদি আস্তে আস্তে গ্যাপটাকে কমায় নিয়ে আসতে থাকি, if we start to slowly reduce the gap, eventually there will come a point when the gap size will be nearly equal to the wave front, wavelength, and we might as well have the situation of diagram 1. That's possible to achieve. So initially যদি diagram 2 situation থাকে, then reducing the gap size will give us a situation of diagram 1, which is a good case of large amount of diffraction. But the question did not mention us that that's the case. So how would you know?
স্যার, এটা কোয়েশ্চেনটা ফেরত যেতে পারবেন প্লিজ?
Yeah, sure. এই যে এখানে 37. সো প্রবলেম যেটা আমি ডিফাইন করছিলাম সেটা হচ্ছে যে আমাদের তো ইনিশিয়াল কন্ডিশন বলে দেওয়া নাই যে এরকম ছিল, এখান থেকে আমরা লার্জ অ্যামাউন্ট অফ ডিফ্লেকশন পাওয়ার জন্য কি করতে হবে। যদি এটা বলে দেওয়া থাকতো যে ইনিশিয়ালি আমাদের ফ্ল্যাট ওয়েভ বের হচ্ছিল এন্ড বর্ডারে ডিফ্লেকশন হচ্ছিল, সো উই ডিড নট হ্যাভ দ্যাট মাচ ডিফ্লেকশন, নাও উই ওয়ান্ট টু হ্যাভ এ লার্জ অ্যামাউন্ট অফ ডিফ্লেকশন, সো হোয়াট শুড উই ডু, then we could definitely choose option choice D. This would be a correct valid answer. But
হ্যাঁ তো
আচ্ছা,
স্যার
anyway,
ওরা কেমনে লাইক বি রেখে ডি ডি কে কেমনে চুজ করলো যদি লাইক কিছু না যেহেতু বা কিছু বলা
that's
নাই।
that's essentially what I'm trying to tell you, that I cannot explain the ground on which they chose the correct answer of this question because there is not enough information given in the question to make an informed choice. That's what I just told you. I'm not telling you this is the correct answer. I'm not. To be honest, no one should be able to tell you the correct answer for this question because there is not enough information for you to choose the correct answer. বুঝছো?
জি স্যার।
এটা হচ্ছে ভেজাল। আচ্ছা, আমরা পরের কোশ্চেনটা দেখি। এরপরে হচ্ছে যেটা আলাপ করতে আসছিলাম সেটা হচ্ছে, আচ্ছা, নাম্বার 40 দেখো। এই কোশ্চেনটা অ্যাকচুয়ালি ডিফিকাল্ট না, বাট এই কোশ্চেনের যে ওয়ার্ডস, দ্য স্ট্রাকচার অফ দ্য কোশ্চেন ইন বেসিক ইংলিশ ভোকাবুলারি অর সেন্টেন্স কনস্ট্রাকশন, ওইটা পড়ে এই কোশ্চেনটা বুঝাটা অনেক ডিফিকাল্ট। কোশ্চেনটা পড়ে একটু সবাই বুঝার ট্রাই করো। I'll help you to solve it, but I want all of you to read and try to make sense of the content of the question in the first place. Try that. আচ্ছা, এটা করলে কি তোমাদের ভিউ উল্টায় যায়?
ইয়েস স্যার, উল্টায় আবার
Wow.
সোজা হয়ে যায়।
Sir, shock transverse wave কি ভ্যাকুয়ামে ট্রাভেল করতে পারে না?
বলো, এই কোশ্চেনের মিনিং কি? What do you understand for the meaning of this question? Anyone?
The number of wavelengths traveled by the wave in 1 second.
Correct. So, how much is the distance covered by in 1 second?
395.
395 meter per second. So how many wavelengths does it cover within the distance? By all means, this is basically the frequency of the wave. Because think about it. If a wave has 10 hertz frequency, and it covers, let's say, 1 meter distance in 1 second, within this 1 meter distance, you're gonna have how many waves? 10 waves. Because every second it is producing some number of waves, and the number of waves produced in 1 second is basically the frequency. So this question is basically asking what is the frequency of that light, only in a different set of wording. Or in other words, I can tell you the value of frequency is the same thing as how many wavelengths of that wave exist within the distance the wave covers in 1 meter. Oh my god. আচ্ছা কয়টা বাজে? I cannot see that.
প্রায় 7:40
7:30 বাজছে?
7:40.
কি বাজবে স্যার?
আচ্ছা ঠিক আছে শুনো, I'm gonna stop the recording and close the class, but before I disconnect from the Zoom, I'd like to show you something. Okay, I have Zoom. Can I stop the recording? Stop the recording.